I feel like science experiments lately have only been for kids. And as a grown adult, sometimes I just want to make some crystals. And I'm going to today. And if you're also a grown adult who just wants to do some science experiments, I give you full permission to do so. But if you're also a kid, if you want to do this, have some adult supervision. If you're an adult, you also may need adult supervision. I don't know you. So today I'm going to make crystals out of a number of things that I have around the house, and I can also get at my local grocery store. So organized. So what you're going to need for this experiment is a mason jar or a jar that's meant to hold really hot liquids that won't shatter to pieces and hurt you. A spoon, cotton string, and or pipe cleaners. Something to suspend the string from. I'm using popsicle sticks. Optional is food coloring. You can also use a scale. I'm using a scale to make sure I'm making really super saturated solutions. If you're making multiple crystals out of different things, I suggest labeling them. I'm using index cards. And then we have the materials that we're making the crystals out of. Most commonly, what I've seen online is a borax crystal, which makes really cool looking, almost geodes. I also have salt. Love a good salt crystal. And I'm also using sea salt. I wanted to see if there would be a difference between sea salt, which might have more than just sodium in the sodium chloride. It might have some potassium in there. I just want to see if it made a different crystal than iodized salt. So we're going to see. I'm also using sugar. And then the wild card for me is calcium chloride. This is, I guess it's pickle crisp. It's supposed to make your pickles crispier. I just saw that it was calcium chloride and I figured I'd give it a try. So let's see how that goes. Oh, and boiling water. I have a kettle over here with hot boiling water. Okay, let's get started. Let's make crystals. Never done this before. Let's start with iodized salt. Turning the kettle on. I'm gonna put in 90 milliliters of iodized salt into this jar. Just after I open it. Does anybody else ever get their fingernail under the metal part and then just annihilate their finger? I'm trying to avoid that at all costs. Okay, cool. Okay, 90 milliliters. Wow, that's a lot of salt. Okay, you know what? 96 sounds good. That's fine. And then 475 milliliters. Here we are. Oh my God. Getting hot. All right. These were questionable decisions. How am I going to fit that much water in this jar? That's good. You know what? I think we'll call it at 360. And then we shall mix. Wow, it's taking a while to dissolve. If you like watching paint dry, you'll love my videos. I guess if you like watching salts dissolve into a solution, you'll love my videos. For the love of Pete. I guess this is good. It means that I can't dissolve more salt in here because you're basically cramming as much of the salt in there as possible before it gets to the point where the water just can't dissolve more. Okay, so now I'm going to make a shape, I guess, with this pipe cleaner. Since sodium chloride is cubic, I'll make a little cube. This is what science looks like, okay? Pipe cleaners in a dream. Okay, I made a cute little square. I'm gonna take my string and tie it. Very cute. Suspension. And then I'm gonna tie this on the popsicle stick. Mother of pearl. Okay, boiling, hot. All right. All right, now I'm going to dip. Look how careful I'm being. Wow. Dip, dip, dip. And then suspend. Wow. Now I'm going to go put this on a shelf and let it crystallize. And then I am going to cover it just so that other stuff doesn't get in. Iodized salt's going to take about 24 to 48 hours to get visible crystals. So we'll see what happens. Okay, what's next? We have sea salt. And this is basically sodium chloride with some impurities. I'm going to put 75 milliliters into this jar. 75 milliliters. Okay, I'm just going to start. God. Oh my God, chaos science. 73. All right. That's got to be something. Okay. And then 1 pint of hot water. One thing to note is that my water where I live is probably pretty hard, meaning it already carries minerals in it. So that might kind of change the result of the crystals. That is something to consider. And it's getting really hot. Okay, now let us mix. Mix. And this time I'm going to add some food coloring to make it pretty. And since it's sea salt, I'll make it blue. You know what? I should probably clean the spoon between each one. That's a good idea. Science. Oh, that is satisfying. Aha, okay. Okay, for this one, maybe I'll make a little shape at the bottom. Kind of want to see what it's like for the crystals to grow just on the pipe cleaner on a string, basically. Okay. Dippy dippy, dippy dippy, dip, dip. Okay. See you in 12 to 36 hours. It's still hot. Next is calcium chloride. I found this in the pickling section of the store, but we're not making pickles. So naturally, I'm gonna also dye this one green because pickle.
Yummy!
90 milliliters of calcium chloride. 90 milliliters. That was a satisfying sound. It smells like science. I actually don't mean that ironically. It actually smells like science. I don't know what it is about this. It smells like a lab. I don't know why. Probably shouldn't be smelling it. And then fill it with hot water. Let's watch Kara burn herself for the 3rd time today. All so you could see me pour water into a jar. Oh! Watch. I kind of wasn't expecting that, okay? Oh! Oh, cool. So calcium chloride is hygroscopic. It might be having actually a reaction. Okay. Oh my God. What? It's like splattering everywhere. But then it stops immediately after I stop pouring it in. I probably should have looked this up a little bit more before I decided to do this. Am I going to die? I have children to raise. I mean, look at it. It's kind of weird. It's like separated. I'm going to get a towel. Okay. This seems safe. It's just calcium and chlorine. Am I making a chlorine gas? This is a very good reminder to double check chemical reactions of the things that you're experimenting with. For example, don't mix bleach with like vinegar, right? You can create a chlorine gas that way and possibly die. This apparently is creating an exothermic reaction, so releasing heat as the calcium and the chlorine separate. God, it'd be so interesting to see what the temperature is. Got our meat thermometer. Right now, the jar is only like, I don't know, not even a quarter full. It's sitting at 175 degrees Fahrenheit. Let's see if we can prove that it's an exothermic reaction while I pour more hot water in. Well, before I do that, let's check the temperature of the water. So 193, 194. So if it goes above that, maybe we can reasonably assume that it is a exothermic reaction. It's not going up too much, but it is bubbling a lot. That is so interesting. I mean, I think I need a little bit more of a controlled environment to actually see if it's the reaction I think it is. I'll show you one more time. Should have had a towel. Maybe you need a towel to do this. And maybe don't do this one, okay? Oh, see, yeah. Oh, nothing like wondering if boiling hot water is going to bubble over onto your hand. I wonder what's going to happen when I stir it. That's actually kind of cool. It's like making little tornadoes. Man, there's something about that smells like a lab. Originally, I was going to add green food coloring because pickles, but because of the exothermic reaction that I think happened, I'm going to make it red because red is hot. Hot. Red. You can see how cloudy it is already. It's super saturated. Anyone with a uterus looks at this and is like, that looks familiar. Nice. One thing to note about calcium chloride is that because calcium chloride is hygroscopic and absorbs moisture from the air, you're going to get really small crystals as a result. So don't get your hopes up for this one. But I just wanted to see what it was like. And I got a lot out of that. I'm going to make like a little geode starter at the bottom and then kind of have a little string going up. Dippy dippy. We shall see you, calcium chloride, in a few hours. Should only take a few hours. Okay, so let's make some sugar crystals. Making sugar crystals requires a lot of sugar. Just fill the glass half full, so 175 milliliters or so, and the rest with boiling water. I feel like if you did this science experiment in school, whether elementary school up through high school, you had a cool science teacher. I had really cool science teachers. Shout out to Mr. Massey and Mr. Preacher. But we never did this one. So what the heck? As always, stir. To no one's surprise, that's sticky. So for the sugar one, you're supposed to let it completely cool after all of the sugar is dissolved before you put in your pipe cleaner or string. And let's add some food coloring. When I think of sugar, I think of Powerpuff Girls, so pink. Aww. In honor of the Powerpuff Girls. It's always so satisfying. I'm really learning my limitations of how long I can hold a boiling hot glass, which is a lot longer than I thought it would be. So I'm gonna let that completely cool before I add the pipe cleaner, or at least let it cool slightly. In about 24 to 72 hours, you should start seeing sugar crystals. Pretty cool. Last but not least, let's look at some borax. I had to take a time machine to 1950 to get this box of borax, so good luck finding yours. For borax, we're gonna add 120 milliliters of borax, and then fill the rest of the pint glass with water. Hot water, boiling hot water. 120. Okay, all right. Where am I gonna put this? I'm gonna go dump some in the toilet. That's close enough, 130. And now fill it with boiling water and let it dissolve completely, creating your super saturated solution. I do feel like I'm running a weird coffee shop right now. Coffee shop of the future. Okay, give it a stir. So borax is sodium borate. Apparently it's used as just like a household cleaner, which I've never done. This one takes a long time to dissolve, so you're gonna have to put your back into it. It's not dissolving. It's honestly, it's probably not dissolving because there's just not enough water for the solid to go into. For this one, I'm gonna add purple because I think it looks pretty. There's a lot at the bottom. Probably just not enough water. So for this one, I'm going to make almost a little net out of pipe cleaners. Great. So get a little bit of string, go ahead and suspend it. Bob's your uncle. Actually, Bob is my uncle. Hi, Uncle Bob.
Hello.
There you go. Borax crystals form really, really quickly comparatively. So I'll give it 3 to 6 hours and you should see some visible crystals by then. So let's talk about the science behind why crystals actually grow in an experiment like this. When your solution cools or evaporates, the dissolved material has nowhere else to go. So it starts to crystallize on solid surfaces like the pipe cleaners or string that you put in the solution. So let's use table salt as an example. Sodium chloride. Salt dissolves into positively charged sodium ions and negatively charged chloride ions. And when a solution becomes super saturated, some of those ions begin to cluster. This is called nucleation. Nucleation is basically the seed of a crystal, the very core of a crystal. As the nucleus of a salt crystal forms, more and more of those sodium and chloride ions will start sticking to one another in a cubic pattern. And the growth isn't linear either. It's actually exponential. It'll accelerate as more surface area becomes available to stick to. And then it'll start slowing down as the solution gets depleted of those sodium and chloride ions. And it eventually reaches that asymptote. Now that all 5 of our solutions are set up, it's a waiting game. In part 2, I'll reveal what the crystals actually look like and talk about the science behind how they formed. But in the meantime, if you want a step-by-step guide of how to do this experiment at home, check out the link below to thecosmicgeologist.com. See you next time.